Hey guys, welcome to the Python thread tutorial for beginners. So first of all, what is a thread? So a thread is an individual and separate unit of execution that is the part of a process. Now what is a process? A process is simply a running program. So for example, if you run a browser, it's a process. If you run a video game, it's a process. Now, inside this process, multiple threads can work together to accomplish a common goal. And threads allows the program to run in parallel. That is the single most important benefit of using threads. So let me give you an example. So when you play a video game, it has to handle few tasks. For example, it has to handle the graphics and the user interface. And if you are playing the multiplayer game, it has to handle the networking. And all those things it has to handle in parallel because it has to remain responsive at all the times. So how does this video game handles those parallel tasks? The simple answer is threads. It can assign one thread for graphics, one thread for user interface, and other thread for networking. So by using threads, the video game can always remain responsive and it can run the task in a parallel way. Now let me explain threads using this diagram. So you can see this whole blue box here is a process and the threads exists inside this process. So in this process, you can see three threads. Now inside those threads, you can see there is a code and local variable. So a thread is a lightweight process that exists inside the process. Also, a thread is a sequence of control flow. The difference between the thread and the process is that the thread exists entirely inside the process and share its resources. So let's say inside this gray box we have the global variables. The each thread will be able to share those global variables, and in addition each thread can have its own local variables and its own control flow to work with those local and global variables. Now, a single process may have multiple threads of execution. And as I already said, that threads are useful when an application wants to perform many concurrent tasks on a shared data. Now, let me give you one more example. So, think about a browser. It has to handle the landing pages or the animations, or if you want to open multiple website on different tabs and you want to run video in one tab and if you want to do another task in other tab, most of the time the browser always remains responsive and the browser can handle multiple tasks at the same time. So it uses threads to always remain responsive. Now there are two different kinds of threads. One is a kernel thread and other is a user space thread or a user thread. Now kernel threads are the part of operating system, while user space threads are not implemented in kernel. The user space threads can be seen as an extension of function concepts in programming languages. Now each process have at least one thread and that is the main thread. So if you don't even create a thread inside a process, it has at least one thread and that is process itself. Now let's talk about the advantages of using threading. So the first advantage is multi-threaded programs can run faster on computer systems with multiple CPUs because these threads can be truly concurrent on multiple CPU computer systems. The second advantage is the program can remain responsive to input at all the times. This is true both for single and multiple CPU computer systems. Now, the third advantage is threading allows to do something else while a thread is waiting for a IO task or any other task to complete. So it always remains responsive. The next advantage is some programs are easy to express using concurrency, which leads to elegant solution. And as a result, they are easier to maintain and debug. So some programs or some processes are inherently concurrent in nature. And the next advantage is threads of process can share the memory of global variable. So as I have already shown you in the diagram previously, that multiple threads can share the memory of the global variables at the same time. So if a global variable is changed in one thread, this change is valid for all the threads. A thread can have local variables also, as we have seen in the diagram. Now let's talk about some of the issues or challenges you will face while programming threads for a program. The first challenge is the scheduling. So to execute a threaded program, it must rapidly switch between threads. So a program should be able to switch between threads efficiently and conveniently. The second issue or challenge is the resource sharing. So as I told you that multiple threads can share the same memory of the global variables. So since threads share this memory and other resources, it must be careful because operation performed in one thread could cause problem in another thread. The next challenge you could face is of synchronizing of the threads. So threads often need to coordinate their actions, and as a software developer you may have heard about race condition of threads, which means the outcome depends on the order of thread execution. And often for synchronization we use locking primitives. Now that was the general description about threads. Now let's talk about the threads in Python. So in Python, a thread is an object like any other object that can hold data. This object can also be used to run with methods. The object also can be stored in the data structures, and this object can also be passed as a parameters to the methods. Also in Python, a thread can also be executed as a process. And during the lifetime of a thread, it can have various states. Now in Python, there are two modules which supports the usage of threads, and these two modules are thread module and threading module. Now there is one thing to note here is that the thread module has been considered as deprecated for quite a long time. So often users are encouraged to use the threading module instead of the thread module. So if you will see in Python 3, the thread module is directly not available, but indirectly you can use underscore thread to use the thread module, and this is to remain backward compatible with the previous versions of the Python. Now the difference between the thread module and the threading module is that the thread module treats the thread as the function, while the module threading is implemented in an object-oriented way. So in the next videos, I will show you how to use these two modules in Python to create threads and handle threads in Python. In the last video, I have given you a brief introduction about threads and threads in Python. In this video, we will discuss about a module called thread module. Now, if you remember in the last video, I have told you that thread module is considered as deprecated in Python 3. But if we want to use thread module in Python 3, we can still use thread module using a module called underscore thread, and this is for backward compatibility. So I just want to give you a brief demo about thread module in Python 3 so you will have some idea about thread module in Python 3. So let's get started. So first of all, in order to use thread module, you need to import it. And then generally you will write thread, but in order to use the thread module in Python 3, you need to use the underscore thread here. Okay, so thread module is not directly available, but it's available using this underscore thread module. And for printing and giving some delay to our functions, we are going to import a module called time. Now, using thread module, it's possible to use functions in separate threads. So we are going to create a function and then we are going to execute this function in separate threads. So let's define a function, and I'm going to name my function as print underscore epoch. And if you don't know what is epoch, epoch is the start of January 1st 1970, and we are going to try to print the number of seconds from epoch till now. And inside this function we are going to provide two arguments. First is the name of your thread, so I'm going to just write name of thread, and the second argument we are going to give is the delay. Okay, so this is your custom function. You can provide any name here and any number of arguments here. And now inside this function, first of all, I'm going to create a counter. So I'm going to just write count, and I'm going to initialize this count with 0. Now inside this function, what I'm going to do is I'm going to loop around, and inside the loop I'm going to provide some delay so we will be able to see the thread execution. So let me just provide the while loop here, and we are going to just check whether this count is less than 3, and inside this while loop we are going to sleep for some time using the time module. So I'm going to just write time dot sleep, and we are going to just pass this delay argument inside this sleep function. So I'm going to just write delay here, which will be the delay in seconds. So for example, if I provide the delay of 1, then our while loop will sleep for 1 second. Now after this we are going to increment our counter. So I'm going to just write count and then plus equals 1, which is going to increment the value of counter by 1. Now after this, in order to see whether our thread is working or not, we are going to print something. So let's print something using the print function. So what we want to print? So let's say we want to print the name of the thread, whatever name we will provide for the thread, and then I'm going to just give some indicator here. Let's say this is some line, and then we are going to print the time since epoch. So in order to print time since epoch, we will use this time module, and then we just need to use the time function inside the time module. So using this print function, we will know which thread is executed and at what time it's executed. So now we have our function, and now this function we want to execute inside the thread. So in order to execute this function inside the thread, first of all, I'm going to use this thread module, and there is a special function inside this thread module which is called a start new thread function. So I'm going to use that function. So let's just call this function, which is start underscore new underscore thread. Now if you hover over this function, and when I press Control on Windows or Command on Mac, and then I hover over this function, you will be able to see the signature for this function. So this function takes 3 arguments. First argument is the function which we want to execute inside the thread. Second argument is args, which we provide to our function as tuples. So second argument we need to provide as tuple, and inside this tuple we will provide the number of argument which we want to provide to our function. And third argument is the kwargs option. And this kwarg is an optional dictionary for the keyword arguments. So let's provide the function name first of all, and our function name which we want to execute is print underscore epoch. And you need to remember that you need to provide this function name without any parenthesis. Okay, so just provide the function name as the first argument. Second is the number of arguments. So we have provided two arguments for this print epoch function. So we need to give these two arguments in the form of tuple. So first argument, let's say, is the name of the thread. So we are going to just say that this is the thread 1, which will be the name of this thread. And the second argument is the delay in seconds. So let's say I want to provide 1 second delay in the while loop. So it will sleep for 1 second. This delay we are providing in order to see the thread execution, because thread execution is so fast that it will be difficult to see the execution of threads without this delay. Now I told you that the third argument is the optional argument, so we will not provide the third argument to this start new thread. So this statement is going to create a new thread and it's going to execute this function inside this new thread. So till now we only have one thread, so let's create the second thread. And to create the second thread you need to repeat this function, which is start new thread, and then you need to give the name to your thread. So I'm going to give the name thread 2, and let's just change the delay. So here I'm going to provide the delay of 3 seconds to the thread 2. So now we have created two threads, and this function will be executed in both the threads. So let's see if this code works or not. So I'm going to just run this script, and you will see as soon as I run this script, it exits without printing anything. And this is because thread takes some time to be created, and we need to wait for the thread creation. So we need to provide some mechanism to wait for the thread creation. And this wait we can provide in two ways. One is we can just provide the blank input function which waits for the input. So using this input function, we will wait for some time until these threads are created, and now we will see if this works or not. So let's run this script once again and let's see what happens. So you can see now you will be able to see these print statements, and you will see that first of all thread 1 is executed, and then thread 1 is executed once again because we have provided only 1 second delay between the loop inside this thread. So thread 1 will be executed faster than thread 2. So first of all, thread 1 is executed and the epoch time is printed, and once again this thread 1 is executed because the delay time is less, and then thread 2 is executed and the epoch time is printed here, and then thread 1 is executed once again, and at the end you will see that thread 2 is executed 2 times, because you can see that here we have the counter limit which is less than 3. So let's try to increase this limit to 5, and let's see how many times this print statement is printed. So let's run the program once again and let's see what happens. So once again this thread 1 is executed 2 times, and then thread 2, and then thread 1 is executed 3 times once again, and then thread 2 comes, and you can see rest of the threads are executed then. So here you can see thread 1 is executed 1, 2, 3, 4, 5 times, and thread 2 is executed also 5 times. So in this way you can start multiple threads and execute different functions inside those threads. Now I told you there is another way of waiting, and this is by providing the while loop. So I'm going to just provide while 1, and inside this while loop I'm going to wait forever. So I'm going to just say pass, and this is an infinite loop which is like waiting. So I'm going to just close this script first of all, and then run the script once again, and then you will see the same effect which you have seen in the case of input function also. Now here one more thing to consider is the return of this function. So if this function which you want to execute inside the thread returns successfully, the thread will silently exit. But when your function terminates unexpectedly, then unhandled exception will be thrown and the stack trace of that exception will be printed on the terminal. So if this function throws, then stack trace will be printed and this will be an unhandled exception. So in order to avoid this unhandled exception, you can also provide the try catch block here. So here you can provide try and then I'm going to provide some space here and here also, and after this code I'm going to just write except, and inside the except you can provide any error, so you can print that this is an error. So inside this print function you can just write that this is an error, or anything which you want to write inside this except block you can write using the print function, or whatever you want to do in order to handle this exception you can do inside the except block. So let's run this script once again and let's change the delay here. So I'm going to provide the delay of 2 seconds and here I'm going to provide the delay of, let's say, 4 seconds, and let's run the script once again, and this script runs and you can see after 2 seconds the thread 1 print statement is executed, and then after 4 seconds thread 2 print statement is executed, and this thread execution you will be able to see in those intervals. So this is how you can use thread module in Python 3. In the last video we have seen how to use thread module in Python. Now in this video I'm going to show you how to use threading module in Python, and I'm going to give you some introduction about threading module, how to create threads using threading modules, and how to use threading module. Now threading module is more powerful and it has more higher level support for creating threads in Python. So let's see how to use threading module in Python. So in order to use threading module, first of all we need to import it. So I'm going to just import threading module, and once threading module is imported we will be able to use threading module. The second module which I'm going to import here is the time module, which we have also seen in the last video, because we are going to create the same function and we are going to use this function using the threading module which we have seen in the last video. Now I'm going to create the same method which I have created in the last video also, which is print epoch. So I'm going to just copy this method in order to save time, and then I'm going to just paste it here. So now we have our function which we want to call using the threading module, and we want to create some threads using this threading module and call this function inside those threads. So first of all I'm going to write this condition which is for the main method, which is if name is equal to underscore underscore main underscore underscore, and under this condition what I'm going to do is I'm going to create two variables. Let's say first variable name is t1 for thread 1, and then I'm going to call the threading module to create a thread. Now inside this threading module there is a class called thread which we will use to create threads. So just call thread class here, and constructor of this class takes several arguments. When you hover over here inside the parenthesis, you will see the signature of this thread class. So it can take the target, it can take the name of the thread, and arguments also it can take in the form of tuple, and it can also take the keyword argument in the form of dictionary. So for our purpose we need to call the function which is print epoch, so we need to provide a target. So in order to provide a target we are going to just write target equals and the name of the function. So the name of the function is print epoch which we are going to call, and this you need to give without the parenthesis. So just remove the parenthesis in front of this method when you use it as the argument in front of target. The second argument which we want to give here is the arguments which this function takes. So this argument we can give using the args parameter. So I'm going to just write args equals, and then in the form of tuple I'm going to give the name of the thread and the delay to the thread. So let's give the name to the thread. Let's say this is thread 1, and the delay which we want to give here is 1. So this statement is going to create one thread, and let me create one more thread in order to create multiple threads. And instead of T1, I'm going to change the name to T2. So we have T1 variable and T2 variable. And in the args, I'm going to change the name of the thread, which is thread 2. And let's say I want to give this delay of 2 seconds to the function using the thread 2. So now we have two variables T1 and T2, which is an instance of the thread class. Now using T1 and T2, we can call a method called start in order to start the thread. So I'm going to just call T1 variable and then call a method called start, which is going to start the thread T1. Similarly, I'm going to call the instance T2 and I'm going to call the method start on this instance T2 also. So start method we use to start the threads. Now if you remember in the last video, when we have created the thread using the thread module, we have given this condition which is the infinite loop, and this infinite loop we have used to wait until the execution of thread is completed. Now in the threading module, which is the new module, this facility is available using a method called join. So on T1 instance, I can call a method called join, and on T2 instance also I can call a method called join, and this join method waits until thread 1 and thread 2 is completed its execution. And then at the end we can print something. Let's say we are going to print that everything is done. So I'm going to print done here. So let's rewind what we have done inside this script. We have imported threading module and time module, and then we have created the function which we want to call using the threads. Now in order to create the thread using threading module, we need to call the class called thread inside the threading module. Now this class constructor takes several arguments, and right now we have given two arguments to this thread constructor, which is the target, which takes the name of the function which we want to execute using this thread, and second argument we have given here is the args, which is the argument which we want to give to the function which we want to execute. Same we have done for the thread 2 also. Now the start method on these instances is going to start the thread for T1 and T2, and the join method we have used to wait until thread 1 and thread 2 is completed their execution. So let's run this script and let's see what happens. So I'm going to right click and then run the threading example Python script, and you can see straight away that this output is printed here. Similar output we have seen in the case of thread module also. So in this output, thread 1 is printed and the epoch time is printed, and then thread 2 is printed, which is printed using the thread 2. So this output is printed using the thread 1, and thread 2 output is printed using the thread 2. And because we have given different intervals for thread 1 and thread 2, that's why we can see that thread 1 is printed and then thread 2, and then thread 1 is printed 2 times, and then thread 2 is printed, and then thread 1 is printed once again 2 times, and then rest of the thread 2 outputs are printed. Now let's take one more example, and what we are going to do in this example is we are going to create two different functions, and we are going to try to call these two functions using these two threads. So the first function I'm going to create here is the print underscore cube, which is going to print the value of cube of the number which we will provide as the argument to this function. So I'm going to just write print here, and then using this print statement I'm going to print the value of cube of the number. So here I'm going to just write cube, and then I'm going to provide these curly brackets, and then I'm going to call the format method after this string. So let's call the format method which we use in order to format a string. Now inside this string we want the cube of the number, so we will just multiply this number 3 times. So num asterisk num asterisk num, which is going to print the cube of the number. Once again, let me just copy this function, and then I'm going to create one more function, and this time I'm going to name my function as print square. So I'm going to just write print square here, and then I'm going to just write square is equal to, and here I'm going to just print the square of the number. Now in this statement where we have created t1 and t2 instances, the target we can change, which is the name of the function. So now our target is print cube and print square. Without the parenthesis, we need to give the name of these function. So print cube and print square, and arguments have also changed. So earlier print epoch used to take 2 arguments, and now we just want to give 1 argument to the function, and let's say it's 2. And also the print cube function takes 1 argument, and let's say it's 2 also. Now let's run this script and let's see what happens. So you will see that there is an exception here, which is some kind of a weird exception which says that exception in thread 2, and this exception is this print square argument after asterisk must be iteratable, right? So the problem here is we need to give a comma here which tells this parenthesis that this is a tuple value. Okay, that's why it's giving the exception. So if your function takes 1 argument, then you need to give the value of that argument and then give the comma so that it's able to understand that it's a tuple. And then once again when you run this script, you will see the value of cube is printed, which is 8, and square is printed, which is 4. So this cube value is printed using thread 1 and square value is printed using the thread 2. So in this way you can also call multiple function using multiple thread instances using threading module. So this was a brief introduction about threading module. In the last video, we have seen how to use threading module to create threads in Python. Now in this video also, we are going to see how to create threads using threading module, but we are going to see in this video how to subclass from the thread class which is available inside the threading module and then create threads out of that class instance. So to start with, I have the same method which is print epoch, which I want to call inside the thread. So now here after this method, what I want to do is I want to create a class. So I'm going to create a class, and the name of the class I'm going to give the name as my thread, for example. And one thing we need to do here is we need to subclass from the thread class, from the threading module. So we are going to just call first of all threading dot thread. So we are subclassing from the thread class. Now inside this my class, first of all we are going to define the init method. So let's define this init method, and in this init method we are going to pass 2 arguments, same as this print epoch function. So first argument will be the name of the thread and the second argument will be the delay. So let's provide these 2 arguments. First is the name and second is the delay. Now after this, inside this init method we need to call the parents init method, which is threading.thread.init. So we are going to just call threading.thread dot underscore underscore init method, which is going to call the parent init method, which is threading.thread, right? Now, once you have done that, we can just simply define some local member variable for the name. So first of all, self.name is equal to name, and self.delay is equal to delay. So now once we have our member variables, what we need to do next is we need to override a method called run, which is available inside the thread class in threading module. So I'm going to just define a run method, and we are going to override this. So first of all, what does this run method do? So the run method is the entry point for the thread. Now in the previous video, if you remember, we have called the start method on the thread class, right? So the start method starts the thread by calling this run method. So under the hood, start method calls this run method. So if we override this run method, that means when we call the start method from the thread class, this run method is going to be called. So now we can do some logging here. So what I'm going to do is I'm going to print first of all start thread, and then I'm going to print end thread. Now between the start thread and end thread logging, I'm going to call the print epoch function, and this print epoch function is going to take two arguments, which is name. So I'm going to just pass the self dot name, which we have assigned to the member variable, and second is the self dot delay. So once again, when we call the start method on the instance of this my thread class, this run method is going to be called by the start method automatically, because we are subclassing from the threading.thread class. Now once we have our run method and we have created the init method, we can create some instances of my class. So I'm going to create some instances. For example, t1 is equal to my thread, and then we are going to pass those two arguments. First is the name. So let's say the name is thread 1, and the delay we want to provide here is, let's say, 1 second, because this delay is going to go to the print epoch method, which is this one, right? Once again, we are going to create the second instance, let's say t2, and once again we are going to call the my thread class, which we have subclassed from the thread class, and once again we are going to give these two arguments. First is the thread, so this time I'm going to name it as thread 2, and the delay I'm going to give here is 2 seconds, let's say. And now after the instance is created, we can call the start method and the join method on these two instances. So let me just call t1 dot start, and then we are going to call the t2 dot start, and once we have the start, which is going to start the threads, we are going to just call the join method. And by now you already know what this join method do, which is to wait for the thread to be completed. So I'm going to just call the join method on t2 also, and let's run this script and let's see what happens. So I'm going to run this script, and you can see, first of all, start thread has been called, which is from the logging of this print method, and then thread 1 is printed and the epoch time is printed, and then thread 2 is printed and the epoch time is printed. Because we have given the 1 second delay for the thread 1, so thread 1 will be iterated faster than thread 2, because we have provided the delay of 2 seconds for thread 2 and 1 second for thread 1. As soon as the thread ends, we can see this print statement, which is end thread, and after the end of the thread 2, we can see this print statement, which is end thread 2. We can also print here. So let's print some more things here. So we can print the name of the thread. So I'm going to just write self dot name, and we are going to do the same for the end thread also. So I'm going to just print here also self dot name. So we will know which thread is starting and which thread is ending. Once again, I'm going to run the program, and now you can see start thread 1. So thread 1 is started, and then thread 2 is started, and you can see first of all thread 1 is ended, and at last thread 2 is ended. So this is how you can subclass from the thread class, which is available inside the threading module. Now, inside this threading module, there are some special methods which we are going to see now. So the first method is, so let me just go after this start of the threads. So here, what I'm going to do is, first of all, I'm going to use the print function, and inside this print function I'm going to call the threading module, and there are some special methods. For example, first of all, we are going to see what is the active count of threads. So what are the number of threads which are there inside this program? This is going to print the number of threads. Now the second method which I'm going to show you is the threading. First of all, let me just call the threading dot, we are going to call the current thread. So this is going to print the current thread which is active right now. And third method which I want to show here is threading dot enumerate, and this enumerate method is going to enumerate the number of threads which are active. So let's run this program once again and let's see what happens. So I'm going to just run this program, and first of all you will see 3 is printed using this print statement, which is threading dot active count. So active count is going to give you the number of threads, and you already know that we have created 2 threads and one main thread is already available. So total number of threads are 3 here, which is printed. Now the current thread here, this print statement prints this output, which is the main thread. So right now at the time of this print statement, main thread is active. Now this enumerate method, as I said, is going to enumerate over all the threads which are available. So main thread is available, and then we have created thread 1, which is this one. This is the name of the thread 1, and then when I scroll here, you can see thread 2 is available. So total 3 threads are available: main thread, thread 1 and thread 2. So these methods you can use to just find out how many threads are there, what is the current thread, and you can also enumerate over all the threads. There is one more method, so I'm going to call this method here, and I'm going to print it inside the print function, and this time I'm going to use the instances. So t1 dot, and there is a method available here which is get name, which comes from the thread class, and because we are subclassing from the thread class, this and because we are subclassing from the thread class, this get name is available inside the my thread class also, and same we are going to do here also. So print and then t2 dot get name. So this is going to give you the name of the thread by default. So I'm going to just run this script once again, and you can see this is going to print thread 1 and this is going to print thread 2. Now you might wonder why this name is thread 1 and thread 2. Because this get name method is going to give the value of self.name, which we have assigned using this name argument. So this name is overwritten in the subclass, which is my thread class, and that's why it's giving us thread 1 and thread 2 name, which we have provided. If we change this name, let's say T1 and T2, and once again we run the code, you can see the name also changes to T1 and T2. So this is how you can subclass from the thread class, which is available inside the threading module. And we have also seen some of the method which are available inside the threading module, which are useful to us. In this video, we will see how thread synchronization works in the case of multi-threading in Python. And we will talk about how to use locks in the case of thread synchronization. So first of all, what is thread synchronization? So thread synchronization is defined as the mechanism which ensures that whenever two or more threads are executed in parallel or concurrently, and if they are sharing the same resource, in that case all the thread should not work simultaneously or parallelly on the same resource. So let me explain the thread synchronization problem with the diagram. So in this diagram you can see there are three threads, and all these threads are sharing the same resource. It can be a global variable, for example. So as long as all these threads are accessing this shared resource one by one, not at the same time, everything will work fine. But the problem arises when two or more threads try to access the same global variable or shared resource at a particular time. And this kind of situation is called the race condition. So a race condition occurs when two or more threads can access the same shared data, and they try to change the value of this same shared data at the same time. And whenever this kind of race condition occurs, the value of the variables may be unpredictable, because if two threads are working on the same global variable at the same time, you will never know which thread has worked on this variable. So the result is the unpredictable value of a variable. Now let me explain this problem with an example. So I have this sample code in which in the first line I'm importing threading module, and in the second line I'm just declaring a global variable. Now I have two functions here. One is thread task and other is main task. Now inside this thread task function, I want to increment the value of x every time by 1. So this is the code for this, and I want to increment this value by 1 10 times. So that's why I have used this for loop in the range 0 to 9. So it's going to increment the value of x 10 times inside this loop. Now because this x is a global variable, I have just added this global keyword in front of x. So our function knows that this x is not a local variable, it's a global variable. So this function is simple enough. It just increments the value of x 10 times inside the loop, and this x is this global variable which we have declared outside this function. Now in the main task, what I'm doing is I'm creating two instances using the threading module with the help of thread class. This we have already seen in the last video, how to create threads using threading module. So nothing new in this. I have created two instances, T1 and T2, and I'm passing the target is equal to the function name, which is this function, which is thread task. So both the threads will call the same function, thread task, and then I'm just starting both the threads with the help of start function, and then I'm just using the join methods on both of the instances. Now here inside our main if condition, I'm just calling our main task in which our threads are created and executed, and then at last I want to print the value of x when all the thread execution has been completed. So let's run this script and let's see what happens. So you can see here the result here is 20, which is expected because we are incrementing the value of x 10 times using two threads. So the value of x will be incremented 10 times by thread T1 and 10 times by thread T2, and as a result the value of x becomes 20. But as soon as I increment the value of this range. Let's say this is 10,000 and I want to just execute this program once again. There is no problem until now. We can just run this program again and again. We will not see this problem because we are incrementing the value of x 10,000 times with a single thread. So we have two threads and the result is 20,000, which is absolutely fine. Now let's increment the value of range once again to 100,000, and now I want to show you the problem. So as soon as you do this, you can see that the thread synchronization problem occurs. So here you can see the result is not 200,000, which we were expecting, because for such large value, this scenario of thread synchronization is happening. So the two threads try to work on the same variable at the same time, and as a result, the value of x is unpredictable. So this thread synchronization problem you will see when you try to work on a same variable multiple number of times. So in this case, we have 100,000 iterations and both the threads try to iterate over the same variable using two threads, and the result is unpredictable. Let's try to execute this once again. So you can see the result is always different every time I execute this program because the result is unpredictable. So how to solve this problem? So one way of solving this problem is by using the locks. So first of all, let me just change this program and try to use locks in this Python script. So to use locks, what you can do is you can declare a local variable here. For example, lock is equal to threading dot a class called lock. So this is going to give you an instance of lock. Now this lock class have two methods. One is acquire and other is release. Now acquire method is used to lock and release method is used to release the lock. So let me just complete this script and then I will explain what does these functions do. So what I'm going to do is I'm going to pass this lock instance as an argument of the thread task function. So I'm going to just write args is equal to, and then we will just pass our lock instance as an argument of this thread task. Same we will do for the second thread. And because we have passed this argument, we need to add this argument here also. So I'm going to just pass the lock instance as an argument of this function. And now at last, what we are going to do is just before we change the value of the global or the shared data, we use this lock variable and call the method called acquires. And just after you finished changing the resource or the shared data, you use a method called lock.release. So once again, we have passed this lock instance which we got from this lock class as an argument of this function. So this is the lock instance, and there are two main methods inside this lock class which are acquire and release. This acquire method you use to acquire the lock. This lock can be blocking or non-blocking. So this acquire method takes one argument which is true or false. By default, the value of argument is true, which means that this acquire is blocking by default. So what does this lock.acquire will do? It locks the access of the shared variable. In our case, this is x, and at this time only one thread can work on this variable, whatever thread have the access to this function at a particular time. So until and unless one thread execution is completed on this variable, after that this lock is released. That means that the other thread can work on this variable using the lock once again. So whenever second thread wants to try to access this variable, it will just lock the access to this variable first of all, and then work on this variable, whatever you want to do. You want to increment the value or change the value of x, and then release the lock. And releasing means that we once again want to allow the other thread to work on this shared resource. So this mechanism will allow only one thread to access this shared resource at a particular time, so the thread synchronization problem will not occur. So now let's just run the program once again and let's see what's the result. So you can see this problem, and this problem is coming most likely because of this problem, because we haven't provided args as the tuple. So we need to provide this arg as a tuple. So always remember, whenever you want to pass any argument using this args keyword, you need to pass them as tuple. So once again, I'm going to just try to run this program, and you can see the result is whatever we expected. So because we are incrementing the value of x 100,000 times, and there are two threads which are working on the same variable, so we get the 200,000 result which is expected. Now let me run this program again and again, and you can see every time now we get the expected result, which is 200,000. So this is how you can solve the thread synchronization problem using locks. So this is how you can use locks to synchronize your threads in Python. I hope you have enjoyed this video, and I will see you in the next video.